Welcome back, children. In the previous video you learned how to convert a simple frequency into more than and less than cumulative frequency. Now we are going to learn how to convert a cumulative frequency, more than and less than frequency, into a simple frequency. Let us see how do we convert a more than and less than cumulative frequency to a simple frequency. First we will see the conversion of less than cumulative frequency to a simple frequency. So heading is conversion of cumulative frequency into a simple frequency. We know there are two types of cumulative frequency, less than and more than. So first we are going to discuss with conversion of less than cumulative frequency to a simple frequency. This is the example. Marks less than 5, 10, 15, 20, 25, 30, 35. So mark less than 5, 10, 15, 20, 25, 30, 35. Number of students is given as 1, 3, 12, 19, 26, 30 and 40. Now this is a cumulative frequency. We are going to convert this cumulative frequency to a simple frequency. So when we are converting the cumulative frequency to a simple frequency, it should be written in the form of class interval and frequency. For less than and more than cumulative frequency, your table will be written in the form of less than or more than. When you convert it into simple frequency, you have to frame out the table with two columns, namely class interval and frequency. Now let us see how do we convert it. Less than 5, marks less than 5 means what? Which is the marks less than 5? Less than 5 should be 0 to 5. How do we frame this class interval 0 to 5? How to frame it? Here you can find out the difference between each and every values here is 5. 5 plus 5, 10. 10 plus 5, 15. 15 plus 5, 20. 20 plus 5, 25. 25 plus 5, 30. 30 plus 5, 35. So we have the class size as 5. So less than 5 means it should be in the range of 0 to 5. So your first class interval is 0 to 5. Less than 5 means it should start from 0 to 5 because the class size is 5. So first class is 0 to 5. So what will be the frequency for 0 to 5? Only 1. 1 is the frequency. Less than 5 means it is automatically 5. Nothing other than that. Then comes the next one, less than 10. Less than 10 means what? It should be a class interval of 5 to 10. Less than 10. The numbers less than 10 means 5 to 10. So next class interval is 5 to 10. And the difference is 5. 5 plus 5, 10. Now for less than 10, what should be there for less than 10? That means less than this 10 for the class interval. Less than 10 means difference between 3 and 1. That is given here, difference between 3 and 1. Difference between 3 and 1. Okay. So 1 minus 3 I have written, that doesn't matter. It is 3, difference between those two. 3 minus 1 is equal to 2. 3 minus 1, that is equal to 2. Likewise, the next one is less than 15 means what? It should be 15, 10 and 15. Class interval is 10 and 15. And it should be the value 12 which is deducted from the previous value. 12 minus 3, that is 9. So first frequency is 1 itself. Second frequency is 3 minus 1, that is 2. Third frequency is 12 minus 3, that is 9. So which is the next one? Less than 20 means 15 to 20. So in order to get the frequency, less than 20 means value between 15 and 20. Therefore, the existing frequency should be subtracted with the previous frequency. Existing frequency is 19, previous frequency is 12. 12 minus 19 or 19 minus 12. 19 minus 12 is equal to 7. Here it is 26 minus 19. So write down the highest value. I have written it as, here also it is 30 minus 26. Here it is 30 minus 26. 30 minus 26. Here it is 26 minus 19. 26 minus 19. And here it is 40 minus 30. So that is class less than, marks less than 35 means it is the class interval 30 to 35. That means the class frequency of that class 40 minus frequency of the previous class. 40 minus 30 is equal to 10, because between 30 and 35 means the frequency between these two. So it is 40 minus 30, answer is 10. Hope it is clear to you. So this is how we convert the marks less than cumulative frequency to simple frequency. I hope it is clear to you. Next we will move on to how to convert more than cumulative frequency into a simple frequency. Just now we converted less than cumulative frequency into simple frequency. Now we are going to convert more than cumulative frequency into a simple frequency. More than cumulative frequency. So here the heading is given as wages more than 100, 110, 120, 130 and 140. Frequencies are given as 48, 44, 32, 12 and 5. Now how to convert it? More than 100. So for that we need to write class interval. If it is more than cumulative frequency, your question will be written in the form of a table more than cumulative frequency with the value of frequency on the other side of the column. But when you convert it into simple frequency, what should be your heading? Class interval and the frequency. Okay, so how will you frame out the class interval? More than 100. More than 100 means 100 and some other value you have to write. So what will you write? More than 100 means you have to frame out the class interval from 100 to 110. So more than 100 means 100 to 110, because the size of each class here is 100 plus 10, 110, 110 plus 10, 120, 120 plus 10, 130, 130 plus 10, 140. So you have to frame out the class interval as 100 to 110. So when you frame out the classes from 100 to 110, more than, what you have to do is subtract the first two frequencies. More than 100, that means it comes between 100 and 110. Therefore 48 minus 44 will give you the frequency as 4. Next, 110 to 120. That means more than 110. More than 110 means it should come between 110 and 120. As it comes between 110 and 120, you have to subtract 44 and 32. Your value will be 12. Next, more than 120 means your class interval should be 120 to 130. As it comes between 120 and 130, you have to subtract the two frequencies 32 and 12. You will get the answer as 20. Again, more than 130 means the class should be between 130 and 140. Therefore, you have to subtract the two frequencies, that is 12 and 5. You will be getting the answer as 7. More than 130, that means the value which comes between 130 and 140. That is why we are deducting two frequencies 12 and 5. You will get the answer as 7. Next comes more than 140. Definitely, if it is more than 140, it should be 140 to 150. How can we write it as 150? Because you know the size of the class interval so far we have written as 10. So you can definitely write it as 140 to 150. Now, the problem is for 150, if you are writing 150, there is no value for, there is no frequency for the same. So you are deducting 5 with 0. So what will be 5 with 0? If you are deducting 5 from 0, that will be 5 minus 0 is equal to 5, because there is no frequency for the value 150. Therefore, it will be 5 minus 0 is equal to 5. But we have to write it as between 140 to 150, because our question is more than 140. So definitely you have to write the class interval as 140 to 150 with the class size of 10, because we know the class size is 10 and we don't have the value for 150. Therefore, we have to deduct 5 with 0. 5 minus 0 will give you 5. This is how we convert more than cumulative frequency to a simple frequency. This is more than cumulative frequency. I hope it is clear to you. Now, so far we are discussing about the different types of frequency series, isn't it? The class interval series, and we finished learning open-end series, mid-value series, exclusive series, inclusive series, next mid-value series. Then next we are going to learn, we also learned about cumulative more than and less than. Next we are going to learn equal and unequal class interval series, the last type of frequency series which we have to learn. Now once again here I am reminding you all, we are discussing about different types of frequency series. We finished learning the inclusive series, exclusive series, open-end series, mid-value series, less than and more than cumulative series, and finally we are learning equal and unequal class interval. What is meant by this unequal and equal class interval? From the name itself you can answer that. What is an equal class interval? When the classes in a series are of the same interval, it is called equal class interval. For example, 0 to 10, 10 to 20, 20 to 30, 30 to 40. What is the size of the class interval? And there is a continuity. The size of the class interval here is 10 everywhere, throughout. Therefore, it is an equal class interval. Look at the example. Class interval 10 to 20, 20 to 30, 30 to 40, 40 to 50. There is a continuity and the class size is 10 everywhere. 10 to 20, 10 plus 10, 20, 20 plus 10, 30, 30 plus 10, 40, 40 plus 10, 50. Size of the class interval is the same everywhere and there is a continuity. So that kind of a class interval is known as equal class interval. So what will be unequal class interval? This kind of equality will not be there. Let us see what is unequal class interval. When the class intervals are not equal, it is called unequal class interval series. 0 to 10, 10 to 20, 20 to 40, 40 to 70, 70 to 100. There is no continuity there. In some classes, the class size is 10. For some class interval, class size is 20, and in other class interval, class size is 30 or 40. It varies. That kind of a class interval is known as unequal class interval. Here is the example for you. Class interval 10 to 20, 20 to 40. Instead of 20 to 30, it is 20 to 40. Here the size is 10, but here the size is 20. Again 40 to 70, that means here the size is 30. So each and everywhere the size is different. So there is no continuity also. That kind of a class interval is known as unequal class interval. So with this we have finished all kinds of frequency series in the chapter. I hope it is clear to you. Now we are going on to the last topic of this chapter, organization of data. The last topic is univariate and bivariate frequency. What is this univariate and bivariate frequency? Now, a univariate frequency distribution can be defined as the frequency distribution with one variable. You very well know what is a variable. A variable is something which always changes, isn't it? For example, years, production of food grains in tons. Okay, years 1960, 61, 62, 63, it is a variable, and by the side you have another variable, production of food grains in million tons, that also varies. So year is depicted with one variable. Year is also variable, the other one is also variable. So the year which is represented by the production of food grains. So year on one side and the production of food grains on the other side. So it will be easy to draw the graph even. But if there are more than one variables, that kind of a frequency distribution is known as bivariate frequency distribution. Let us see the example to understand. Example here is sales of a company in various years. Year will be given and on the basis of the years we can depict the sales of a company. Now let us see what is a bivariate frequency. A bivariate frequency distribution can be defined as a distribution with two variables. At a time, two variables will be there. For example, sales and advertisement of a company in various years. It can come like that, isn't it? There can be more, 3 or 4 or more number of variables for a data. So, a frequency distribution where there is only one variable is known as a univariate frequency distribution, and a frequency distribution with two variables is known as bivariate frequency distribution. Now, with this, we have come to an end of this chapter, and there is a homework for you. Based on all the topics that we have learned in the chapter together, I have framed a question for you, and if you do this question, you will be able to reach out to all the topics that we have learned. So try it out. This is the question. Marks secured by 30 students are given below. You can have a look on the data given here, and I'll read the marks obtained by 30 students. The marks are 41, 55, 42, 53, 42, 31, 42, 31, 42, 55, 42, 35, and so on. You can find some marks are repeated here. You can have a look on the marks which I have given here. Just have a look. You can find 41 is repeated so many times, 55 is repeated so many times. So this is a marks data regarding the marks secured by 30 students in a class. It can be marks in English or economics or whatever you want, you can write. Just have a look. 30 students, marks of 30 students is given here. Let us count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Yes, it is correct. 30 students. Now, what I have asked you to do here is arrange the marks in ascending and descending order. From the beginning, what all things you have learned, you can apply it for this problem. In this problem, represent the marks in the form of discrete series. I think it is not clear. Discrete series. Construct a frequency distribution where the class intervals should be exclusive, taking the lowest class as 20 to 30. So that is a hint. Class interval should be in the form of exclusive series, and lowest class should be 20 to 30. Then next question is convert the exclusive series that you have made into less than and more than cumulative frequency distribution. So whatever you have learned, you can practice it here. So first you have to make an exclusive series, then what with the lowest class of 20 to 30, then exclusive series again you have to convert into less than and more than cumulative frequency. Okay, so try to do the problem without making any errors. Thank you.